Hi, 7th grade. Today we're doing the final lesson from What Do You Expect, which is lesson 5.1. It's going to start on page 100 of your book. And the title for this section is called Binomial Outcomes. And this particular section is called Expected Values. So this is the first time we're going to be talking about binomial outcomes and kind of the special properties that they have. This is the only section we're going to do in lesson 5. Okay, our Gotta Check is page 100, and we're going to be doing Gotta Check A2. And then your homework for tonight is page 106, numbers 3 to 8. And our bell ringer today is page 85, number 19A. This bell ringer is another one of those free throw situation problems. So it gives you a percentage, a free throw percentage, and you need to make the area model and determine what are the percentages for 2 points, 1 point, and 0 points. Okay, let's get started. So today we're going to be talking about binomial outcomes. And binomial outcomes are a special type of probability because they follow a unique pattern. So we know that binomial, if you think about bi, the root of bi is 2. And binomial, this root means number. So we're looking at outcomes that have 2 potential outcomes. Okay, so binomial outcomes are situations where we have 2 outcomes per each trial. And some examples of situations that have 2 outcomes per trial are a coin toss, okay, or for example, situations where you have like a boy or a girl. There's a 50% chance of a baby being born a boy or a girl. Another possibility is questions correct on a true-false test. So correct or incorrect on a true-false test. And that's what we're going to be looking at today. What we're going to find out is that situations like this follow a neat and kind of interesting pattern in terms of the number of outcomes they have. Okay, so right now I'm working on page 100. And I'm going to be looking at the situation that they give us. So they tell us that a quiz has 4 true-false questions. And I'm going to work on the example A1, which is what's the probability that if you guess on all 4 true-false questions, what is the probability that you will get all 4 correct? Okay, so that's what we're looking for. So with 4 true or false questions, what's the probability that I get all 4 correct? Okay, so in order to do this, we're going to make a sample space. So here I go with question or event 1. It's possible that I could get it correct or I could get it incorrect. Okay, right? Then I'm going to make my question 2, so I'm going to use a tree diagram. So it's possible that I could get my second question correct or incorrect. So I'm going to put in my corrects or incorrects. Okay, so now I have 4 possible outcomes. When I go to question number 3, it's possible that I could get that correct or incorrect. So I'm going to make some more trees so I could get that correct or incorrect. And I'm going to fill in my corrects or incorrects. Okay, and then by the time I get to question 4, okay, I'm going to have lots more options. So I need little branches to come off each of these. And you can see I'm running out of space, but that's okay. So I could get correct or incorrect. I could get correct or incorrect, correct or incorrect. And I'm just going to fill in all my probability spaces. There are lots. I got to do this really tiny. Okay, did my best there. Did it really tiny. Okay. What we can see is this is why we talk about the fact that they're binomial outcomes, because the number of outcomes in each trial is going to follow a pattern of 2 raised to a power. and that power I'm going to write as n. That is the number of outcomes. Okay, so I'm going to show you how this works. For question 1, there's 2 possibilities. That's 2 to the first power, which is just 2. For question 2, there are 1, 2, 3, 4 possibilities. So that's going to be 2 squared, which is 4 possibilities. For question 3, I count 1, 2, 3, 4, 5, 6, 7, 8. That's 2 to the third power, or 8 possible outcomes. So I can predict now, by the time I get to question 4, there are going to be 2 to the 4th power, or 16 possible outcomes. Okay? But I still haven't been able to find out what's my probability for 4 correct. So now I'm actually going to go through and I'm going to write out my probabilities. So if I look at my sample space, I'm going to start with my first tree. So I've got correct, 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 correct. That's 1. Then next I have correct, 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 incorrect. Correct, 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 incorrect. Okay? And I'm going to go through and I'm going to write out all 16 possibilities. So you do this with me. Correct, correct, incorrect, correct. And then I'm going to have correct, correct, incorrect, incorrect. Okay, so now I've done these 4. And I'm just going to kind of check them off as I go to make sure I've got them all. So next up, I have correct, incorrect, correct, correct. That's this one. Then correct, incorrect, correct, incorrect. That's this one. Next up, I've got correct, incorrect, incorrect, correct, correct, incorrect, incorrect, incorrect. Okay, interesting, right? So I'm going to go through and continue filling these out. So my next, so right now I should have 8, 1, 2, 3, 4, 5, 6, 7, 8, and that's all the corrects. So now my next row is going to start with the incorrects. So I've got incorrect, correct, 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 incorrect, correct, correct, incorrect. Then I'm going to do this row, incorrect, correct, incorrect, correct, incorrect, correct, incorrect, incorrect. So I've gotten these 2. Then I'm going to do this row. So this row will give me incorrect, incorrect, correct, correct, incorrect, incorrect, correct, incorrect. That's these 2. And last but not least, incorrect, incorrect, correct, incorrect, and incorrect, all incorrect. Whew, that's a lot. But I do have 15, right? Or 16, excuse me. I've got 8 on this side, 8 on this side. Okay, so what's my probability of getting all correct? Well, let's take a look. I have only 1 outcome where all are correct. None of these other ones have all correct. So that means out of 16 total outcomes, my probability is 1 over 16. Okay, so now we're going to try the gotta check. So on page 100, we're going to be doing gotta check A2. Pause the video, and then we'll come back and we'll figure this out later. Okay, let's take a look at gotta check A2. So gotta check A2 was the probability of 3 correct. So we were looking for, and maybe I'll do this in red. We were looking for the probability of 3 correct. Okay, so we're looking for exactly 3 correct. I'm going to erase this one, okay, because this one's not going to count anymore. So I'm going to go through and I'm going to circle all the probabilities where there's exactly 3 correct. So there's exactly 3 correct here. There's exactly 3 correct here. This one is not. There's exactly 3 correct over here. Okay, this one I've only got 2. This one only I've got 2. This one I've only got 1. Okay, let's take a look at the other side. So the other side, I have exactly 3 correct over here. But the rest of my probabilities, you can see I've only got 2 correct, 1 correct, 2 correct, 1 correct. Okay, so I'm done. Okay, so my probability of getting 3 correct is 1, 2, 3, 4, and that's out of 16 possible outcomes. Okay, if I wanted to simplify it, I could simplify it to 1/4. Okay, but that's my probability. All right, time for your homework. So your homework is going to be very similar to this. It's page 106, numbers 3 to 8. And your bell ringer problem, again, page 85, number 19A, another area model. Okay? Bye, everyone. We'll see you tomorrow.